All right, welcome everybody. Let's get started. Okay, let's quickly recap where we left off last time. Actually, first I have a few announcements. Let's do that first. Then we'll recap what we did last time and where we left off, and keep going. So my very not legible pink writing has a few notes. One is homework 1 is going to be due next Friday. All right, so you'll normally have a week to do your homework. The content that's being covered on every homework is roughly finished by, say, the Monday before it's due. So we'll be doing the homework on stuff from today, a little bit from last time, and then stuff from Monday. But it wouldn't hurt for you to look at it and see what's going on and kind of get a rough start on it. So that, like I said, will be submitted to Canvas. If you have questions on that, every homework is going to have a posting or a folder on Piazza that you can ask questions. That has proved to be a pretty productive way to get through homework. So you guys can post questions. You all can answer other people's questions if you have it. I will try to respond in a timely way to those. But you guys can use it as your own discussion board. What I will ask is that you don't just outright post answers. That's not helpful to anybody. And I'll just remove the post and tell you not to do that. But you can sort of answer general questions that aren't just specifically giving away the answer. In terms of how I want you to work on homework, I expect you to submit your own work. Right? You can talk to other people in the class as you're doing the homework. You can work together, but I don't want, if I see something that looks like you have exactly the same thing, that to me is that's not what I'm asking for. I'm asking for you to do the homework individually. You're graded individually in the course, so it's kind of a waste of the grader's time and my time if we find that you're all submitting the same thing. Right? We're trying to give you individual feedback. So please keep that in mind. If there's an issue with that, I'll talk to you about it. Let's see. In terms of homework format, actually, I wanted to show you some examples of what I would like you to do on the homework format. Let me see if I can do this. All right. So here's a couple examples of prior homeworks from other semesters. Generally, in terms of format, what you should do is, this is a grad level course, so you have to put some thought into how you submit the homework. You're spending a lot of time on it. You want to communicate clearly the work that you did, the answer that you have, and then any justifying calculations or code that go with it. All right, so this, for example, there's a problem that was given. I think it had, 5 different subparts. So this student has provided a summary page that lists the short answer to every question, right? It's sort of an executive summary. The numeric values that were computed, if there's describe or justify a certain plot or something like that, that is provided in the summary here. So that the grader can look through and quickly see whether there's an issue in any specific spot. Right, if you go through and you got the right answers, we'll look at the right answers and then quickly look at the work that justifies it. If it all makes sense, good, move on. But if there's a problem, then we can really focus in and see where specifically to give you feedback on that. Okay, so summary page, and then you have to attach to your homework everything that justifies the stuff that's on the summary page. If you just give the summary page and no justifying work, we can't, what do we do with that? You can't prove that you did the homework assignment. Maybe you just borrowed the answers from somebody else. So make sure you go through, have all the justifying calculations. If there's ease code, you're providing the ease code. You're printing out the code itself. You could print out the formatted equations window. Sometimes that helps or sometimes it doesn't. Please don't print out thousands of lines of table. That doesn't, that's not good. So just all the calculations that are needed, and then any hand calculations that go with it. All right, so kind of in that order, I guess you can use your judgment, but summary page, justifying calculations in code, handwritten notes that go with it. All right. So there's 2 examples. I've uploaded these to Canvas. I guess the question that comes up often is if you're drawing a diagram, say I ask you to draw a resistance network, do you have to put that on the resistance, or do you have to put that on the cover page and in the body of the document? I think as long as it's on the cover page, that's good enough, right? You don't have to duplicate it. So yeah, here's just another student's example. So you want to put some time into making it, a coherent homework assignment so that somebody can figure out what you've done. Any questions on this, on the format part of it? Okay. I think for those of you who had me for undergrad or have had, I think Professor Nellis has a similar approach. There's not going to be any surprises there. Okay, so that's homework. If you have questions on format or any other sort of logistical things with homework, you don't hesitate to ask. That's fine. Let's see. There is, I didn't cover it last time, but in terms of grading on homework, the homeworks are going to be out of, say, I think 20 points each. So the minimum you'll probably be docked for any problem or issue with your homework is 1 point. There may be some cases where it's half a point, but that's kind of the minimum. You mess something up, it's a minimum of 1 point. There is partial credit to be had, right? If you get the answer wrong, that's just a point or two, but you have to, if you make a mistake and it's one minor thing, you'll still get most of your credit. So be sure to show your work and justify that most of the points will come back to you through partial credit. You can drop your lowest homework. So I think we have 13 scheduled this semester. You could do all 13 and then drop your lowest. That would be the best case. You could do 12 and drop your lowest of 0. That's also a possibility, like things come up. But if you're going through the semester and you've already used your drop and you find all of a sudden that something came up, like that's kind of what the drop is for those unexpected things that might prevent you from doing the homework. Okay. Last thing I wanted to mention was exam format. We'll be doing exams in class. The first two will be in class. I think we'll target having them be an hour long. So we have 15 minutes scheduled. So I'll have you show up here 5 minutes early, and we'll stay 5 minutes late, and hopefully we can make that work. If you have accommodations, please come talk to me about that. We'll figure something else out. The final exam, I'm leaning toward doing a take-home final because it's scheduled for like afternoon of the last possible day, which sucks for you guys, and it sucks worse for me because I have to grade them in about 24 hours. So I think we'll do a take-home exam, and it'll probably be in that finals week. But I haven't fully decided on that yet. Okay? All right. Let's see. So let's quickly recap what we did last time just to get back into it here and to clean up a couple things. So we talked about where Fourier's law comes from. There are a couple questions after class I just wanted to clear up. I mentioned this Kn. It wasn't clear what I was saying there. Maybe it's called the Knudsen number. And that, again, is the ratio of the microscale length to the characteristic length of the problem. Microscale length would be something like the distance between adjacent lattice, lattice features or atomic features. And the characteristic length is like the overall size of the body that you're trying to model. Okay, so Knudsen is a person. What else? So there was a question about this factor of 2. So just to clarify what we did here, we multiplied the stop equation by 2 LMS over 2 LMS to get it to look like this. And then in the end, we should have carried the 2 down here. As I said, though, ultimately it doesn't matter because we just care about what is conductivity proportional to. So just to clarify that. And let's see, energy balance. And we left off here where we're taking the limit as dr goes to 0 for this problem where we're trying to solve for temperature as a function of position in the cylindrical body.